Alright, this is Prep Test 63, which was given in June 2011, Section 2, Logic Game Number 1. Let's read the stimulus. Each of 7 candidates for the position of judge, H, J, K, L, M, O, and P, will be appointed to an open position in one of 2 courts, the appellate court or the trial court. There are 3 open positions on the appellate court and 6 open positions on the trial court, but not all of them will be filled at this time. The judicial appointments will conform to the following conditions. Okay, so we've got H, J, K, L, M, O, and P. These are 7 people. They're going to be put on one of 2 courts, appellate or trial. There's 3 slots on appellate. There's 6 slots on trial. And so what that obviously means is that we have 7 people to put into 9 slots. So not all of these are going to be filled. What that also means is that this is an in and out game, because there are 2 groups, and if you're not in this group, then you have to be in this group, and vice versa. Okay, let's take a look at our rules. So our first rule says that L must be appointed to the appellate court. So fine and dandy. How about the next rule? K must be appointed to the trial court. Great. And now let's look at our third rule. H cannot be appointed to the same court as P. Well, what does that mean? It means that if we have H, then we don't have P, meaning that we get the contrapositive. If we have P, then we don't have H. Is this a complete and accurate way to express this rule? Well, no, because we also know that if we don't have P, then we must have H. And contrapositively, if we don't have H, we must have P. Why? Because they cannot be on the same court together, and there's only 2 courts. So either the presence of H or the absence of P will tell us where both of these elements go. So if we take these 4 rules together, all this does is express a biconditional relationship. All it does is express the relationship between H and slash P, and this arrow runs both ways. So really this is a pretty straightforward game. Basically we have one conditional rule. Granted it's a fairly complicated conditional rule because it's a biconditional, but it's still just one rule. And we have these 2 things that just have to be here, which means that we've accounted for 4 of the 7 elements up here, but what we haven't accounted for are J, M, and O. And these guys can go anywhere they want without affecting anything else. And so the only real other inference we can draw from this game is these 3 guys can do whatever they want. Okay, let's go ahead and take a look at the questions. Question 1 is, again, our typical make sure the student understands the rules question. So, which one of the following is an acceptable set of appointments of candidates to courts? Well, we basically have 2 things to test. So let's go ahead and first test out our actual rule. H and P have to be on separate courts. So in answer choice A, H and P are on separate courts. That's fine. Answer choice B, H and P are together on the appellate court. Get rid of it. Answer choice C, H and P are on separate courts. Answer choice D, H and P are together on the trial court. Well, we can't have that. Get rid of it. Answer choice E, H and P are on separate courts. Great. Now let's apply this. L's got to be on appellate. Let's start there. So any answer choice that doesn't have L on appellate, we get rid of. So answer choice A has no L on appellate. Get rid of it. Answer choice C and E both have L on appellate. Okay, fantastic. The last rule is that K has to be on the trial court. Well, in answer choice C, K is on the appellate court. We can't have that, which means that E must be our answer. And if we look down at answer choice E, K is on the trial court, just as we require. So that is the answer to the question number 1. Question number 2 asks us which of the following cannot be true. Well, keeping in mind that J, M, and O are free agents, meaning that they can go wherever they want, this question initially seems like it would be kind of difficult, but you also remember that we have a limited amount of slots. In particular, I'm betting that the appellate and the trial, or the appellate side is going to be much more restrictive than the trial side, especially once we factor in that since H and P have to be on separate courts, we can add this directly to our diagram. The second slot in appellate is definitely going to be taken up by one of H or P. So with that in mind, let's go ahead and take a look at question 2. And let's take a look at the answer choices. Keeping in mind that they want which of the following cannot be true. So answer choice A, H and M are both on the appellate court. Well, if we put M here, H here, L here, and then P here, and then the rest of them go here. That's fine. We can do that. How about B? M and O are both on the appellate court. Well, can that happen? If we put M here and O here, then where's our room for one of H or P on the appellate court? We don't have that. It forces both of H or P to be on the trial court. We can't have that. And so answer choice B looks really good. That is something that cannot be true. How about answer choice C? Ortiz and Perkins are both appointed to the appellate court. O and P are both appointed to the appellate court. L and then P and then O, which means H is over here, dump everything else in trial. So answer choice C also could be true. For the record, I'm using these check marks to indicate could be true, and therefore not the correct answer. How about D? H and J are both appointed to trial. Well, we put H here, we put J here, we put P here, and then the rest of them can go wherever. So this one also could be true, so get rid of it. And finally, answer choice E. O and P are both appointed to trial court. So here, we have K, we put P here, which means H has to be here, we put O here, and then the rest of them go wherever they want. So that's fine. This also could be true, and so is not our answer. So we've convinced ourselves that therefore answer choice B is the answer to question number 2. Let's keep going. Question 3 once again asks us which of the following cannot be true. So, answer choice A. J and M are both appointed to the appellate court. Well, if we put J and M here, well, can we do that? We can't do that, because there's only this one slot once we account for the fact that L has to be here, and one of H or P also has to be here. So answer choice A should be our answer. For the sake of completeness, let's go ahead and convince ourselves. Answer choice B. J and M are both appointed to trial court. Sure, J, M, because they're floaters, they can do whatever they want. Still, we can put H and P on separate courts. Get rid of it. How about C? M and O are both appointed to trial. Well, again, M and O both can do whatever they want. We can still put H and P on separate courts. Get rid of it. How about D? M and P are both appointed to appellate. Well, now we know that P is here, so H is here. M is here. The rest of them go here. It's possible. Get rid of it. And how about answer choice E? M and P are both appointed to the trial court. Well, now we know P is here, so H is here. M is also here, and then the other stuff can go wherever it wants. So once again, that could be true. Therefore, we've convinced ourselves that answer choice A is the answer to question 3. How about question 4? Now the question says, if Ortiz is appointed to the appellate court. So let's redraw our diagram. Now we have L, we have one of H or P, and now they're telling us that O is also appointed to the appellate court. Well, our knowledge of the question tells us that that means that the appellate court is full, right? Which means that K has to be here, the other one of H or P has to be here, and then everything else also has to be out, which means that J is out and M is out, right? And so this is 1, 2, 3, 4, 5, 6, 7. This is all of our elements. So this is the way that it has to look if Ortiz is appointed to the appellate court. And so now they're asking which of the following must be true. So A, H is appointed to the appellate court. It could be true, but it doesn't have to be true. These can switch. How about B? J is appointed to the appellate court. That can never be true. So let's keep track. A could be true, but that's not what we're looking for. B must be false, which is also not what we're looking for. How about answer choice C? J is appointed to the trial court. Well, yeah, this one must be true, right? So that is what we're looking for. So C should be the answer. Let's convince ourselves. Answer choice D. P is appointed to appellate. This could be true, but doesn't have to be true, because again, these can switch, so get rid of it. And answer choice E, P is appointed to the trial court. Again, for the same reason, because H and P can switch. If P can be here, it can also be there. So get rid of it. So here, answer choice C is the correct answer. Okay, and now we get to the difficult question on this game. Question 5. Which of the following, if substituted for the condition that H cannot be appointed to the same court as P, would have the same effect on the appointment of the 7 candidates? So what it's asking you is that if we basically have one rule in this game, and that is that H and P cannot be on the same court together. Now they're taking this rule away from us. Now they're saying that if all you know is this, that L is here and K is here, but we still want to make it so that H and P split up between these two, we got to find a rule somewhere in answer choices A, B, C, D, and E that does that. And so if you're not familiar with the replacement rules, go ahead and look up my video for replacement rules so you have an introduction to them. The general gist of it is just that whatever the new rule says must give you exactly the same set of possibilities as the old rule. Okay. So let's just go through and see which ones of these we can eliminate. So, answer choice A. H and P cannot both be appointed to the appellate court. So if H is on the appellate court, then P has to be on trial. If P is on the appellate court, then H has to be on trial. So, answer choice A says H means no P. H on appellate means no P in appellate. And P in appellate means no H in appellate. Does this mean the same thing as our initial rule that they can't be on the same court together? Well, no, because what if we put H in trial and P also in trial? If we put them both here together, we don't have any rules that tell us what to do. And so this is an instance in which our old rule doesn't allow this, but our new rule allows this. So that cannot be the answer. How about B? If H is not appointed to trial, then Perkins must be. So if H is not appointed to the trial, that means Perkins is on trial. Well, again, what if H is appointed to the trial? Then we don't get to draw any conclusions. So it's very possible that we could also just put P into trial. So again, answer choice B allows something that our original rule didn't allow, so we get rid of it. How about C? If Perkins is appointed to the same court as Jefferson, then Hamadi can't be. So if P and J are together, that implies that H is not with them. Well, what if it's the case that P and J aren't together? Because remember, up here, we could separate P and J, and it still had to be true that H and P could not be on the same court together. And so it could be the case that, you know, we don't put P and J together, and we put H and P together. Once again, this is a possibility. For example, we can just make an example where P and J are separate and H and P are together, right? So this is a possibility that this rule allows for that our initial rule did not allow for. So that can also not be our answer. How about D? If H is appointed to the same court as L, then P must be appointed to the same court as K. So if H and L are together, that implies that P and K are together. Well, over here, if H and L are together, then it also means that P and K have to be together. So at least it looks tempting to us that, okay, this sort of maps to our old rule. But the question here isn't whether this is a possibility under our old rule. The question is whether they're exactly the same. And so the answer to that question is pretty clearly no. Because what happens if H and L aren't together? Right? Remember that here H and L don't have to be together. You could put H over here with K, we could put P over here with L, but it still had to be the case that H and P were separated. So we don't have any idea what happens when H and L are separate, and so this allows for the possibility of putting H and P together. And so again, this is a possibility that our new rule allows for, that the rule in answer choice D allows for, that our old rule did not allow for, so we get rid of it. And so by pure process of elimination, we know that E is our answer. Let's see if we can affirmatively prove it to ourselves, just to be sure. So answer choice E says that no three of H, K, L, and P can be appointed to the same court as each other. Okay, well, what do we know? We know that we still have these rules. We still know that L's got to be in appellate and K's got to be in trial. Great. So basically what we're left with is we're left placing H and P. And we're told that we can't put three of these guys together. Well, the only way that we can put three of these guys together is if we put both of these guys into either appellate or trial, right? And our rule is telling us that we can't do that. So what is our only other option? Our only other option is to split them. In other words, one of them goes here and the other one goes here, so that you have a 2-2 split. And does that work? Yeah, that's exactly what our initial rule tells us. Our initial rule tells us that, you know, we have to have basically a 2-2 split. L and K are separate, H and P are separate, and so therefore L is with one of H or P, K is with the other of H or P. Isn't that exactly what's going on here? We have to separate these two because 3 of them can't go in the same column. So L is either going to be with H or P, and K is going to be with the other one. In other words, H and P always have to be separate. And so, thinking of it that way, we're therefore convinced that answer choice E is the correct rule to replace our initial rule, as requested in the question.